Okay, so hello everyone. Uh, Today we'll be solving yung ating example problem number 2. So sample problems 2.2 sa ating thermodynamics 2. So the first problem was in the video, binigay ni Sir Kurt. And he asked us to solve yung second problem by ourselves. So solve natin, and then I'll explain the process since nasulat ko na naman. So basahin ko lang yung problem. Single acting compressor operates at 150 revolutions per minute with initial condition of air at 97.9 kilopascals and 27 degrees Celsius, and discharges the air at 379 kilopascals to a cylindrical tank. The bore and stroke are 355 millimeters and 381 millimeters respectively, with a percentage clearance of 5%. If the surrounding air are at 100 kilopascals and 20 degrees Celsius, while the compression and expansion process are PV raised to 1.3 equals C, determine the power of the compressor in kilowatts. So, dun pa lang sa statement ng ating problem, we have a PV raised to N. So, we can deduce from that that it is a polytropic process. And writing are given. So, makita natin yung ating given nandito. So, yung translation ng ating mga given dito, the bore would be the diameter, the stroke would be the length, and yun nga, there's also an N, but let's get to that much later. So, convert na natin yung units into meters. And ating percentage clearance, 5%. So, that's 0.05. And then, ito yung ating N. We're asked to find our work of the compressor. Now, drawing the PV diagram ng process na to, we have our P2 here and our P1 here. So, we have an isobaric process going at these points where pressure is constant. And makita natin dito, V1 prime, so this is the same as V1 minus V4. So, parang yun yung nasa module natin, V1 minus V4. But let's denote it as V1 prime since parang ito yung actual na air na napapakinabangan natin. And then, we have the volume displaced. This is yung naaabot ng piston natin. And we have the V3 here. And ito yung kabuuan na to. This is V1. Okay? Alright. Now, punta tayo dito sa paggalaw ng ating piston. So, when the crankshaft rotates, napupush yung ating piston from the bottom dead center to the top dead center. In which, yung air, kapag babalik na yung piston, nagkakaroon ng suction. And, may napupuntang air dito. However, yung air na napupunta dyan is hindi yung kabuuan ng tank is nafi-fill. So parang merong gap dito. And that is what we call probably the free air capacity. Since yung air na yan gets pushed here much later on kapag magro-rotate na uli yung crankshaft and mapupush yung piston natin. Okay? And we're also given its properties. So let's denote it as PO, P sub O. It means outside. So we have 100 kilopascals and 20 degrees Celsius. Okay. We can also try to find the free air capacity, but hindi naman siya included here. So we'll focus on yung ating V1 prime. So if you want to find yung ating V sub O, you can utilize the PVT relations since it is an isobaric process naman. So, we know na yung ang ating volumetric efficiency is equal to V1 prime, or it could be V1 minus V4 over the volume displaced. Transposing, ang ating V1 prime is going to be equal to the volumetric efficiency multiplied to the volume displaced. And ngayon, we know yung ating volume displaced is equal to the product ng ating pi over 4, yung ating diameter squared, parang sa module it's just D, but I think dahil volume siya, you need to square the diameter, and then yung ating length, and then yung N, which is the revolutions. And I think meron pa tong maliit na N. It's for the number of the acting compressors. But since it's just one, so it's just one. Walang mababago sa formula. Substituting the values. No? So, yun nga. We have the bore as the diameter, the stroke as the length. Down dito. And then, para maging uniform yung ating units, we will convert yung ating revolutions per minute to revolutions per second. Okay? So our volume displaced is going to be equal to approximately 0.0943 cubic meters per second. So it's a flow rate. It's a volumetric flow rate. Store natin kay A. Ano? And our volumetric efficiency, yan ay equal to this formula. 1 plus C minus C multiplied to the pressure ratio P2 over P1 raised to 1 over N. Substituting the values, and remember it's a polytropic process, we will have 0.9084 unit less. Store natin kay B. Now that meron na tayong volume displaced and volumetric efficiency, mahanap na natin yung ating V1 prime, which is here. So yung ating volumetric actually nabaliktad. So yung ating volume displaced na nakastore kay A, and then yung ating volumetric efficiency na nakastore kay B, it's just fine, it's the commutative property, is going to be equal to 0.0856 cubic meters per second. Store natin kay C. Now that meron na tayong V1 prime, we can compute for ang ating work ng compressor. So the conventional formula for this is N MRT over 1 minus N multiplied the pressure ratio P2 over P1 raised to N minus 1 over N minus 1. Okay? What we know na yun nga, MRT is equal to PV. So papalitan natin yung MRT ng ating PV. Okay? So we will have the new formula, NP1 V1 prime over 1 minus N multiplied to the quantity P2 over P1 raised to N minus 1 over N minus 1. Substituting the values, and then doing the unit analysis, makacancel tong meter squared sa baba, may matitira ditong lone unit ng meter. So kilonewton meter is a kilojoule, and kilojoule over second is a kilowatts. Okay? And then finally, once you have done your calculations, the answer would be negative 13.3210 kilowatts. Okay? So I think that pretty much sums up this problem. So ayan, I hope it helps in your studying, since I'm just pretty much cramming as well for the possible quiz on Monday. So yun lang, thank you guys and happy learning!